Planet Earth notes. Earth's shape is a sphere, but it's not a perfect sphere. Earth is a spheroid. That means it's like a sphere, similar to a basketball, but it's wider around the middle, what we would call the equator, because of the intense speed at that location. You may not know it, but near or at the equator, Earth is rotating at about 1,000 miles per hour, but so is everything else at the equator as well. Whereas at the North and South Pole, you're close to or at 0 miles per hour. One of the things that helps keep life on Earth safe is Earth's protective magnetic field. It protects us from harmful solar radiation and acts kind of like a magnet, keeping harmful particles from the sun away from us. We have a protective magnetic field on Earth for two main reasons: because of the makeup of the materials at and near Earth's core, as well as the spinning or rotation of Earth. Did you know that Earth's magnetic north and south pole is different than the rotational axis north and south poles? And it changes over time due to changes in Earth's core. Most people understand that Earth has a tilted axis of 23.5 degrees, but not everyone understands how the tilt is the reason for Earth's seasons. More on that later. Liquid water is key to the survival of most all life forms we currently know of. Earth has plenty of it, for two main reasons. One, because Earth is not too close or too far from our sun, and because of the insulating effect of Earth's protective atmosphere. It keeps our temperatures even. The counterclockwise spinning of Earth is what we call rotation. It causes the sun, moon, and stars to appear to rise in the east and set in the west. To rotate means for an object to spin around its own center point or axis. So let's talk briefly about how day and night cycles work here on planet Earth. So in this clip here, you can see the sun hitting the left-hand side of the model Earth and not hitting the right-hand side. So what that means is that the sun would appear to rise, move through the daytime sky, and set on this half of the globe. And for people on this side of the globe, there would be no sun, meaning it would be nighttime. All because of Earth's rotation. Next, we'll talk about Earth's revolution. No, not the American Revolution. I'm talking about the yearly trip that Earth makes around the sun. It takes about 365 1/4 day to make the oval shape or elliptical orbit completely around our sun. To revolve means for an object to move around or orbit around a different object, like the Earth around the sun. It's a common misconception that when we're closer to the sun, it's warmer, and when we're farther away, it's colder, but that simply isn't true. For example, Earth is at perihelion, or closest to the sun, on January 2nd each year. Step outside on January 2nd in Wisconsin and tell me how warm it is. The real reason for seasons here on Earth has to do with Earth's tilt, and the effect that tilt has on how direct or indirect the sunlight is. Here you can see the effect of direct versus indirect light. As I point the flashlight directly into the camera lens, it's very intense. But as I angle it slightly up or down just a little bit, you can still see the light, but it's not nearly as intense. So when either the northern or southern hemisphere is tilted towards the sun, they get a lot more direct solar energy, and that leads to longer days and more intense radiation, so it gets hotter. In this diagram, the important thing to focus in on is the tilt of the Earth in relation to the Sun. So I'm going to highlight the tilt in both the summer and the winter. The thing to really focus on is where the Sun is directing most of its energy. So on this left side diagram, you can see how most of the solar energy, at least the direct energy, is going to be focused on the northern hemisphere. And that's because of this tilt that I highlighted earlier. Okay? The tilt is leaning kind of into the Sun, if you will. And on the opposite side over here, when we have the tilt now in the northern hemisphere facing away from the Sun, that Sun's direct energy is not focused on the northern hemisphere anymore. Now it's focused on the southern hemisphere. So that means we in the northern hemisphere get a lot less of that solar radiation, and we get it at a much lower angle. It's not nearly as direct. So that is really what leads to the extreme of our summer season, because we are tilted towards the Sun, and our winter season, when we are tilted away in the northern hemisphere. And really, spring and fall are simply halfway points between the winter and the summer season. And the only thing that spring and fall have in common is that the Sun is kind of split evenly between northern and southern hemisphere, because it's falling directly on that middle line that we call the equator. A solstice is a day that the Sun's most direct energy reaches farthest north above the equator or farthest south below the equator. This typically happens twice in a calendar year. When the Sun is focused on what we call the Tropic of Cancer, that's in the northern hemisphere what we call the summer solstice. And that happens on either June 21st or June 22nd. And that's the longest amount of daylight we get for the year. The winter solstice, on the other hand, is when the Sun is focused on that line below the equator that we call the Tropic of Capricorn. And the winter solstice, the shortest day of our calendar year, typically happens on December 21st or 22nd. And finally, we have equinoxes. An equinox occurs when the Sun is directly above the equator, and this causes an equal number of daylight and nighttime hours all across the globe. So 12 hours of daytime, 12 hours of nighttime. So remember this: equinox, equator, equal.